There is the catapult prefab in the folder. I'm going to add that to the scene. And it's just made of 3 cylinders, or rather capsules, put together in this orientation. You will see that the catapult already has an orbital solver attached to it. This is to keep it against the hand, and it's assigned to the left hand at the moment. There is also a script that I've written that is not necessary, but it handles reloading behavior. So what we want this catapult to do is to be held in the left hand and to have a ball positioned between its 2 arms, and that ball should be grabbable, and when you release it, it should fly between the 2 arms off into the distance. How are we going to achieve that? Well, let's break this down into steps. First of all, we're going to position the ball at the center point, which I've already shown is linked in between the 2 arms. We're then going to define another point that is in reference to the right hand control array, and I imagine we'll use an in-between script for that as well. After that, we want to have some trigger events. So the first one is to pick up the ball, the second is to release it. The first one will cause the ball to be held in the correct position, and on the second trigger event we're going to give the ball momentum and physics. So it's going to need a rigid body, and then we'll also use a momentum solver as well, and I'll show you how that works. So let's add a projectile to the scene. I've gone with the classic ball round projectile. I'm going to make it a child of the center point. On this projectile we have a collider, of course, and a rigid body. This has gravity turned off initially because we don't want the ball to fall down onto the catapult. Then we have a solver handler that links this projectile to the right hand. There is then an in-between script, and the transform that we're going to use is the center point of the 2 arms. The partway offset value determines the proportion of the distance from the one end or the other. I want this pullback point to be closer to the hand, so I'm going to put it at about 80% of the way towards the hand. After this, we need to add the momentum solver. In this context, we can think of it as the elastic band not drawn that would be holding the ball as it's pulled back. The acceleration rate is very high, as you would expect from an elastic band, and the springiness is also fairly high. When we run the scene, we can see how this works. Again, I'll use the left shift to position the left hand, and you can scroll the mouse wheel to move it forwards and backwards. I'll then use the spacebar to hold the ball, and while it is working, you can see that there's a lot of jitter. One of the features you can use to remove this is the snap Z. And with that checked, you can see that it's much smoother. The last thing to do is add the interaction events that will allow us to pull it back and release it. We can do this entirely in Unity using the pointer handler component, which I've added to the projectile. This gives you events that can be triggered and customized for the pointer down, pointer up, pointer clicked, and pointer dragged events. We will be using just 2 of them, the pointer down event and the pointer up event. The on pointer down event is linked to 4 changes in the components. The first one, setting the partway offset to 0.8, keeps the ball in the correct position. We set the lifetime to 0 because we want that state to remain indefinitely. We make sure that the in-between component is enabled, and we turn off use gravity because we don't want it to fall. The on pointer up event affects the same variables. we are setting the partway offset to 0, which is a position between the arms of the catapult. We will set the lifetime to be 0.02. This is the amount of time that the ball has to be given momentum as it travels towards this point. After this, the solver will turn off, and we will make sure that when that happens, that the gravity is turned on and snapset is also turned off. The InBetween.lifetime variable that I'm setting in both of these events is not normally accessible from the Mixed Reality Toolkit. There's only a private variable that's there in the solver.cs script. So what we're going to do is go now, and I'll show you which lines I've added in order to make this changeable here, and also to be effective as an event, which it isn't by default. Opening this script in the editor, we can see on around line 90 the original line, which is defining the current lifetime, and after that the other parts that I've added. This simply converts the private variable into a public one, and when setting it, starts a coroutine that, after waiting for half of the lifetime, sets the remaining lifetime to what is left. Making this change means we now have access to the lifetime variable inside the pointer handler events. The values that you see here are a result of some tuning between the lifetime in the on pointer up event and the acceleration rate. When you can balance these well, then you have a nice effect. The last thing we're going to do before we test is, since we're now handling the movement of the ball with events, we're going to begin with the partway offset between the posts. So that about concludes the tutorial. I'm sure there are things you can do that will improve both the functionality and the aesthetic of this catapult, but this gives you a framework to begin using it in your project. Thanks for watching.